Trees are fundamental structures in computer science, used to model problems involving a hierarchy or a sequence of decisions. A tree is defined as a connected acyclic graph and can be classified into different types, such as binary trees, rooted trees, and labeled trees. In a tree, each vertex, or node, is connected to other nodes through edges, and key concepts such as the root, child nodes, sibling nodes, ancestors, and descendants allow for organizing and navigating the tree's elements. Trees are especially useful in data structures and algorithms, where they facilitate the organization, storage, and retrieval of information. In practical terms, trees have fundamental applications in areas such as data retrieval and decision-making. A binary search tree, for example, allows for the efficient location of elements in sorted lists through a logical traversal that follows comparisons between node values. Furthermore, the process of inserting and deleting nodes in this type of tree follows specific rules that guarantee the maintenance of order. Decision trees are also used to model situations where each node represents a decision and the branches represent the possible outcomes. These trees are applied in optimization problems, game resolution, and decision-making under uncertainty. Finally, preorder, inorder, and postorder traversal algorithms allow systematic access to the nodes of a tree, facilitating the analysis and processing of complex structures.